Great, you drew a square. But notice, we were writing the same lines of code over and over again. That would sound so tedious if we were trying to make a huge design and we had to keep writing the same things over and over. Wouldn't it be great if we could just give the instructions once and have the program repeat it for us? Fear not, because we can. To do this, we need to use loops. Loops run a set of instructions multiple times. To see this in action, here's an example that draws a triangle. So if we go down to Replit, they already loaded the code in there. So all we have to do is press run. And lo and behold, a triangle is formed by our turtle. So let's figure out exactly what does a loop do. So the first line, it says for I in range 3. This is the statement that tells the program to run the instructions in a loop. So let's look into the statement a little more. So I is a variable. It is used to keep track of how many times we have ran the contents of the loop. Range 3 sets a limit to how many times the loop runs, in this case, 3 times. Okay. But be careful because the syntax for loops is a little difficult. But as long as you follow 2 simple rules, you shouldn't have any problems. Do not forget this colon right here. That colon signifies that what comes afterwards are the contents of the loop. So if that colon isn't there, you will get an error and you will be wondering why your loop isn't working how you expected it to, even though you copied it down and wrote it. Also, this indent is super important. So similar to how English has spelling and grammar rules, Python has syntax rules. And syntax is basically how we write languages so they're understandable. So the computer understands that the tab means that this code is within the loop. And it understands that this is the start of the loop with the colon. So both of those are essential to making the computer understand what is going on in our program. For example, if we were to get rid of the tab here, we would notice that, oh, hold up. The code doesn't run how we expect it to, and it's because it turns left after it goes forward 3 times. Also, if we were to accidentally forget the colon and we ran it, we would get an error. So those are 2 things to look out for when you're dealing with loops in order to make sure that your code works how you expect it to. So now they want us to take the example code that they provided and modify it slightly so that we can draw a square like we did in activity 1. Now feel free to pause and go back to activity 1 and see what we did and get a little refresher because it has been a minute. But I am here to help you walk through how to do this. So my preference on how to take a look at how to tackle a coding problem is, first, we remember the steps that we want to achieve. So I'm going to get my handy pen out and draw the square again. And honestly, this time it might be useful to like write down the steps from the previous page or to write down the steps as you draw the square. So you want to go straight and then we want to turn left. And we want to go straight, so that's 2 times, and turn left again. And so we want to go straight and turn left again. So that's 3 times that we're doing the same thing. And then we want to go straight the 4th time. And it doesn't necessarily matter if we turn left or not. But for the sake of the loop, we're probably going to turn left again. And so, through drawing, we have deduced that we need to run the code 4 times for each of the sides of the square. So for I in range 4, and then we want to move the turtle forward 50 pixels, just like we did before. And then we want to turn the turtle 90 degrees instead of 120, because if we were to run it with 120, you would see that it just does the triangle, because squares are, their corners are 90 degrees. So let's run it. And bam, we have a square. Feel free to play with the loop, or if you want, you can make the range bigger and see what that does.